today we're gonna talk about very important theoretical concepts that you need to know before we start diving into streams. We're gonna talk about some important concepts, some problems that you might face, or problems that are general in the way data is handled and buffered and all of that. And we're gonna try to get into all of that in this video. This video is very theoretical. We're not gonna code anything, but it's very important because we're gonna talk about these concepts in the upcoming videos. And let's get into it. Yeah. All right. So all streams in Node.js operate exclusively on strings and buffers, or uint8 arrays, unless they operate in the object mode. So basically, the streams in JavaScript or in Node.js operate on strings, or an array or a buffer of type, or basically uint8 array. They operate on these strings or these type of objects, and they flush them into the system, like we saw in the file example, or we're gonna see in the future examples in the future videos. But there is something called object mode that allows the streams to operate with all other JavaScript data types except null. And we're going to talk about buffering. So buffering it's implemented in Writable and Readable, and hence it is also implemented in duplex and transform, because transform and duplex are built on both or implement both Writable and Readable streams. So this data is stored in something called the internal buffer, and the amount of data that can be stored in this internal buffer is defined by a variable called or a property called high watermark, and this is a threshold. It's not a limit. It tries to stop the data from approaching this threshold, just so we don't run into problems. For normal streams, the high water mark specifies the number of bytes that can be buffered. In object mode, it defines the number of objects. So anyway, the buffering is a little bit slightly different between readable and writable streams. So for readable streams, for example, data is buffered when the stream calls stream.push. So it's like this. So basically, the readable stream gets the things that are going to be streamed or read in the future, and it keeps just pushing them. And well, if the system or your script just calls read, so you push a chunk of the stream and you read it right away. But if for some reason you're trying to access this stream, or this stream is actually ongoing, the data is coming from a different source, or it's a file that you're trying to stream, or a video or whatever. If the consumer does not read this data or this chunk or these chunks that are being pushed, then the data sits in the internal queue waiting to be consumed. But there is a problem. Once the data reaches this high watermark threshold, the stream temporarily stops reading from the underlying resources until the data currently buffered can be consumed. So anyway, for the writable stream, when the data is buffered, when we call the writable or the write method repeatedly. Like, remember in the example in the last video, in the file example, and by the way, in the file stream, and later on we're gonna see more examples in the file stream and other types of streams. When you call the function write repeatedly, the system does not really just like write immediately. It just it takes this data and queues it and starts writing them. So as long as the buffer data is under the high watermark threshold, the stream, when you call the function write, will return true, but it will return false when it returns it. The next video is a perfect example to see this in action. Don't skip it. It's very important. So we're gonna talk really quickly about something called backpressuring. And this is actually something that is so important when dealing with buffers, when dealing with streams. So do not treat it lightly. We're actually going to explore it more in either this class or the buffer class, but hopefully in this course. So, when the receiving end of a data transfer has complex operations, like the writable stream just gives, or the incoming source of data just sends you chunks of data, and these are like, let's say they're encoded or they're encrypted, and you have to decrypt them, or decode them, or decode them, then put them in a presentable format, and obviously this is kind of costly. So if these transfer operations are complex, or they're slower, then the data coming from the incoming source will accumulate, which is a problem. Obviously, in order for you to solve this problem, you have to have a delegation system that ensures a smooth flow of the data from one source to the other. Obviously, these are implemented in Node.js, they're implemented in the TCP sockets and Unix pipes. We are going to explore them later on, but for now, these were theoretical concepts. Hopefully, you got what they meant, and I'll see you in the next one, and good luck.